Dear friends, in this video we will find the answers to some of the questions that you are watching on the video screen. On September 24, 2023, NASA's OSIRIS-REx will become the first U.S. mission to deliver a sample of an asteroid to Earth. The OSIRIS-REx spacecraft, which launched on September 8, 2016, collected rocks and dust, an estimated 8.8 ounces, or 250 grams, from the surface of asteroid Bennu on October 20, 2020. After further study of the asteroid, the spacecraft began its cruise back to Earth with the sample on May 10, 2021. This material from Bennu acts as a time capsule from the earliest days of our solar system and will help us answer big questions about the origins of life and the nature of asteroids. When it reaches within 63,000 miles of Earth's surface, about one-third the distance from Earth to the Moon, the OSIRIS-REx spacecraft will release the sample capsule. The time of release will be 4:42 a.m. on September 24th. Traveling at 27,650 miles per hour, the capsule will enter Earth's atmosphere 4 hours later just off the coast of Northern California at an altitude of about 83 miles above the surface. The time of entry will be 8:42 a.m. The capsule will land just 13 minutes later, at 8:55 a.m. a 36-mile by 8.5-mile Area Department of Defense's Utah Test and Training Range near Salt Lake City. Mission team members will retrieve the capsule as soon as possible after it lands to ensure the sample is not contaminated by exposure to Earth's environment. They will fly it by helicopter to a temporary clean room set up at the training range and prepare the sample for transport to NASA's Johnson Space Center in Houston the next day. Scientists at Johnson will care for the sample, store it, and distribute it to the OSIRIS-REx science team and other scientists worldwide. Most of the sample will be available upon request for generations to come. Scientists predict that Bennu formed from pieces of a larger asteroid in the asteroid belt after a catastrophic collision between 1 and 2 billion years ago. Considered a rubble pile asteroid, Bennu is an amalgamation of rocks that are loosely packed and barely held together by gravity or other forces. The asteroid is relatively rich in organic molecules. Its materials also appear to have been chemically altered by liquid water in the distant past, likely when it was still part of the larger asteroid it came from. Here are 3 of the many reasons NASA chose to study Bennu. The asteroid is a remnant from the tumultuous formation of the solar system, unlike any rocks we can find on Earth. On our planet, weather, erosion, and plate tectonics have wiped away evidence of Earth's formation. Thus, Bennu's rocks offer us insight into our own history, a time about 4.5 billion years ago when Earth was first forming. Bennu is rich in organic compounds that make up all known life. There is evidence that asteroids like Bennu delivered these compounds to Earth when they smashed into our planet billions of years ago when the conditions for life were starting to emerge. Most asteroids can be found in the asteroid belt, a ring of asteroids that circles the Sun between the orbits of Mars and Jupiter. The asteroid belt is very far away, so a round trip would take a long time and be much harder to do. Bennu, in contrast, crosses Earth's orbit, so it was easier and quicker to send a spacecraft to Bennu and back. Bennu has no chance of hitting Earth through the mid-2100s. After that, the chance is very slight, 1 in 1,750, or less than 0.1%, through at least the year 2300. In the distant future, Bennu could potentially hit Earth or even Venus, but that cannot be predicted with any accuracy. Indeed, being able to accurately predict the future motions of asteroids like Bennu is one of the science goals of the mission. As the sample capsule descends through Earth's atmosphere, air will enter through its vents, streaming in through a filter that will remove contaminants including water vapor, organic compounds, and dust. It will then flow into a canister inside the capsule that contains the sample. This will allow the canister to come to atmospheric pressure, which will protect it from leaks that could lead to contamination. Once the capsule lands, is retrieved, and delivered to a temporary clean room at the Utah Test and Training Range, the OSIRIS-REx team will hook it up to a tank that will release nitrogen, a gas that doesn't interact with most other chemicals. A continuous nitrogen flow into the capsule will push out invading air. The asteroid sample will be safe for Earth and its inhabitants. Due to the harsh radiation environment in space, there is no chance that the sample from Bennu could contain living organisms. based on studies of other materials from space, including meteorites, cosmic dust, and previously returned samples by NASA and JAXA. About 20 minutes after the spacecraft releases its sample capsule above Earth's atmosphere, it will fire its engines to divert its trajectory away from Earth. The spacecraft will then set out on a new mission called OSIRIS-REx to explore asteroid Apophis, which it will reach in 2029. As soon as NASA confirms that the sample capsule has landed, a team of scientists, engineers, and military safety personnel will fly out in helicopters to retrieve it. They will place the capsule in a metal crate and wrap the crate in multiple sheets of non-reactive plastic material and then a tarp. A harness will then be placed over the crate. The crate will be secured to a cable attached to a helicopter. The helicopter will fly the capsule to a temporary clean room at the Utah training range. Scientists and engineers in the clean room will open the capsule and extract the sample canister. The next day, on September 25th, the mission team will transport the sample to NASA's Johnson Space Center in Houston, where it will be documented, cared for, and stored. Soon after, portions of Bennu's rocks and dust will be distributed to scientists on the mission's science team. Up to a quarter of the sample will be distributed to 233 scientists on the OSIRIS-REx team, who represent 38 institutions globally. 4% will be given to the Canadian Space Agency, and 0.5% to Japan Aerospace Exploration Agency. The rest, about 70%, will be preserved at NASA's Johnson Space Center for scientists outside the mission team and for future generations of scientists. These are some questions from the audience. Thanks for watching and subscribe the channel.